remember my parents telling me that the doctors told them that I had a 50% chance to live to be 5 years old. My parents just weren't given much hope for me to live a long and healthy life.
At that time, most of the patients became very sick during childhood, and a large number died during childhood.
We lost children at 8, 9, 10 years old.
We had little in the way of hope. We had little to offer patients. There was tremendous frustration that more progress had not been made.
Other than airway clearance and pancreatic enzymes, we didn't have many tools.
We were pretty much still fighting a rearguard action against cystic fibrosis. We were dealing with the symptoms systematically, one by one, each one as they arose. We were behaving aggressively because we believed that the gene would be discovered.
I was a junior faculty member at the University of Michigan, got there in 1984, had developed a method to try to travel across chromosomes by jumping instead of walking, which at the time was an important advance potentially because it might enable us to get to the gene for cystic fibrosis from markers that were somewhere nearby but were actually quite a distance away.
A group in Toronto had just found that there were DNA markers that were associating with CF, and so Francis got on the phone with Lapchi Choi.
And Francis came in because he had the technology of chromosome jumping. So I said, Francis, you're jumping, but you're jumping from a place quite far away from the gene. And so perhaps we can collaborate because we knew exactly where we were, and then we have a very good so-called physical map of the region of the gene. So perhaps we can collaborate.
Jack Reardon's lab joined the effort given his expertise in other aspects that were going to be important, like being able to look at sweat glands.
Jack was very important in the discovery of the cystic fibrosis gene because he had made a number of cDNA libraries.
We had sweat gland samples from patients in the CF clinic at sick kids as well as people without CF, and we cultured those cells.
The first piece of gene that we identified or we isolated was from his library, from the so-called sweat gland cDNA library.
It really was this extraordinary collaboration between Francis Collins, Lapchi Choi, and Jack Reardon that pulled together really the most innovative and state-of-the-art teams.
And finally, after many fits and starts where many of us began to despair about whether this was a solvable problem, in the summer of 1989, the data emerged to say, we found it, this is it.
It was amazing the day they announced the discovery of the CF gene.
Being on the cover of Science magazine and knowing they were possibly close to finding a cure for CF, or at least understanding where CF comes from.
The researchers were excited, the families were excited, the caregivers were excited.
Especially, working with patients day to day on the floor, so we were excited for what was to come and what that meant.
We were at home and the phone rang. My mom picked up the phone and another CF mom called to tell her that they found the gene, and she just started crying immediately because she knew it meant there was hope.
So it was really an exciting time for our community, for our scientists, but most of all for the parents and patients. It gave them a new sense of hope.
Well, the first time I saw the cover of the magazine presented to me in a small celebration at the hospital, I had a tear in my eyes.
On the day of the publication of the science papers, there was a big ceremony in the Hospital for Sick Children. Families of CF patients and CF patients themselves, they came to the hall, and this was really, really touching. When we came into the hall, they were all standing and clapping hands.
And I felt a little bit of an accomplishment because I finally did something for the patients, for the families.
This was a huge breakthrough, not just for CF, but for genetics and medicine in general. So it was a big deal, and I think everybody had a clear appreciation for how special and important it was.
The discovery of the gene for cystic fibrosis was an exhilarating time.
And we believed, somewhat naively at the time, that from the gene would automatically cascade tremendous understanding of the pathobiology of the disease and then a cure.
Shortly after we found the gene, I think all of us had the expectation that this was a disease where gene therapy would be particularly appropriate.
Nobody really fully anticipated the tremendous difficulties that lay down that path.
Even once people began to realize, hey, this is going to be more challenging, the fact that we knew CFTR, we knew the cause, still said, hey, this is the direction we need to go after, just means it's going to take more than we originally thought.
Because of the variation of the disease presentation among different patients, even patients with the same mutations, we thought there must be other genetic factors influencing the presentation or the symptoms of cystic fibrosis. So it's that let's look for the so-called modifier genes.
It was several more years before the other approach, namely trying to develop a drug, a small molecule, really got fully pushed. And I give huge credit to the Cystic Fibrosis Foundation and to Bob Bell for deciding to make a bet on that at a time when I think a lot of people thought the chance of success was going to be very low. But here we are.
The Cystic Fibrosis Foundation had to change how it did business. We used to support academic institutions mainly with grants, but then we recognized if we really were going to translate that wonderful knowledge that we had learned from the academics and the test tubes to new therapies, we had to bring in a new partner, and that was industry.
Well, the discovery of the cystic fibrosis gene opened the door to not only a better understanding of the disease, but the application of the detection of the CF gene mutations for newborn screening.
And we're able to identify patients with CF, or the vast majority of patients with CF, very early in the course of their lives, and gives us an opportunity to intervene.
This year, over 10 million babies will be screened for cystic fibrosis.
Evidence keeps accumulating that the sooner we get in and slow down the progression of the disease, the better off these kids will be.
Now we have patients that we're seeing right at the beginning of life through newborn screening. We now have the promise of therapies that will be game-changing in the sense of preserving lung function and improving nutrition in ways that we previously couldn't do. So it is a completely different landscape.